Hi everyone, I am Santhi from Department of Mathematics and Statistics, Bhavan Vivekananda College. I am here with my lesson 28 from linear algebra on eigenvalues, eigenvectors and diagonalization. In this lesson, I am going to introduce eigenvalues and eigenvectors of a matrix. Let us first define what is eigenvector and then eigenvalue of a matrix. An eigenvector of an n by n matrix A. So n by n matrix compulsory it is a square matrix. A is a non-zero vector x. So the vector should be a non-zero vector. That means a column vector like x means a column vector like this. X such that, so this should be a non-zero vector such that ax is equal to a into x is equal to lambda into x for some scalar lambda. That means multiply a with the column matrix x, column vector x, then that should give you some lambda scalar into again x, the vector x, and that x should be a non-zero vector. Then you call this vector x to be an eigenvector for the matrix A. Now, similarly, let us see the next line. Then any scalar lambda is called an eigenvalue of an n by n matrix A if there exists a non-zero solution x for the matrix equation Ax is equal to lambda x. Now we are talking about eigenvalue lambda. So when do you call a scalar to be an eigenvalue for a given matrix? If there exists a non-zero solution x for the matrix equation, what is that matrix equation? Ax is equal to lambda x. This is the same as the above equation. So, for this lambda, you call it as an eigenvalue if you could find a non-zero solution for this matrix equation. Means if you can get a non-zero vector x, a column vector x which is non-zero, satisfying the equation x is equal to lambda x, then you call lambda to be an eigenvalue of A. So this eigenvector and eigenvalue definition we have to learn together. So in general you can say if you take a square matrix A and then take a scalar lambda, then consider the equation Ax is equal to lambda x. If you have for x not equal to 0, if the equation Ax is equal to lambda x, then you call x to be an eigenvector and lambda to be an eigenvalue for the matrix A. Now let us look at some points. First point, for any matrix A, it is always true that A into 0 is equal to lambda into 0, because if you take this equation Ax is equal to lambda x, Ax is equal to lambda x. If I take in place of x 0, compulsory it will be satisfied lambda into 0 for any lambda. Then do you call 0 to be an eigenvector? No, because this is always true. It is true for all values of lambda. But what is eigenvector definition? If you go back and see, it is a non-zero vector. Eigenvector should be a non-zero vector. That is why 0 cannot be considered as an eigenvector. An eigenvector can never be 0. But you have for any matrix A, I can have Ax is equal to 0 into x. May be possible. Only for few values of x. It may be possible. Then what happens? Lambda can be 0. 0 can be an eigenvalue, whereas 0 cannot be 0 vector can never be an eigenvector. So for any matrix, you can have a 0 eigenvalue, but you cannot have a 0 vector as an eigenvector. That is the first one. Then, so you can say again the same points I am here quoting. An eigenvector x must always be a non-zero vector. And the second point, an eigenvalue lambda can be 0 also. Now let us look at the procedure to check whether a vector is an eigenvector of a matrix. For this, let me take this example. Matrix A is given, which is a 2 by 2 matrix 1, 6, 5, 2, and there are two vectors given, u is equal to 6 minus 5 and v is equal to 3 minus 2, and then determine whether u comma v are eigenvectors of A. If so, find the corresponding eigenvalue. So let us look at the solution. So first let us write a vector x is an eigenvector of a matrix A if there exists a scalar lambda such that Ax is equal to lambda x. Then we call it as x is said to be eigenvector. So here given what is the matrix given, A is equal to 1 6 5 2, a 2 by 2 matrix, and then here it is given a vector u is equal to, first let us look at the first vector. It is, first vector is 6 minus 5. 6 minus 5. Now let us check what is A into u is equal to. 1 6 5 2 into 6 minus 5 is equal to 6 minus 30, and then 30 minus 10, which is equal to minus 24, and then 20, and these two are multiples of 4. So if I take 4 common, I get it as minus 6 5, but here I can observe u is 6 minus 5. So let me take minus 4 common. So I will get here 6 minus 5. Minus 4 into 6 minus 5. That is equal to minus 4 into u. Therefore, what do you have here? Au is equal to minus 4 into u, which implies there exists lambda is equal to minus 4 such that A into u is equal to lambda into u. Hence, u is an eigenvector of A and the corresponding eigenvalue is lambda is equal to minus 4. Minus 4. Yeah. Now let me check for the second one. What is the second vector given to us? Second vector given is 3 minus 2. So now I have v is equal to 3 minus 2. Now let us check what is A into v. A is 1652 and into v is equal to 3 minus 2. If I multiply, I will get 3 minus 12 and then 15 minus 4, which is equal to minus 9 11, and it is not at all equal to, you cannot if you try to write it as a multiple of this, you will not be able to. So it is not at all equal to any lambda into minus 11, any lambda into 3 minus 2. That is, there does not exist any scalar lambda such that AV is equal to lambda V. Therefore, V cannot be an eigenvector for E. This is what, how do we check eigenvalues and eigenvector, not how do we check an eigenvector for a given matrix. This is what, how do we check when a vector is given, whether it is an eigenvector of a given matrix or not, and then hence we can find its eigenvalue. Here we are with two practice problems. First one is x is equal to vector minus 1 1, an eigenvector of matrix A is equal to 5 2 3 6. If so, find the eigenvalue. And the second one is a matrix A is given 3 by 3 matrix and x is equal to 1 minus 2 2 given. Then is x an eigenvector of A? If so, find its eigenvalue. Now let us look at the procedure. to find whether a given scalar is an eigenvalue of a matrix. Previously, we worked out examples to find whether a given vector x is an eigenvector. Now we will find the procedure to find a given scalar lambda is an eigenvalue of a given matrix or not. So here I will give steps. First one, number 1, consider a square matrix A n by n, and the second one, let lambda be a scalar. Right. Then if lambda is an eigenvalue of MA, then there must exist a non-zero vector x such that Ax is equal to lambda x. That implies there exists x not equal to 0 such that Ax minus lambda x is equal to 0. That implies there exists x not equal to 0 such that A minus lambda I into x is equal to 0. See here, if I take x common, x is a vector, you have taken common, then here one identity matrix should remain, not one scalar. So after you take out x common, here I identity matrix, where here I will write here where I is n by n identity matrix. So that implies the matrix equation A minus lambda I into x is equal to 0 must have a non-zero solution. So then what do you do the next step? For this we need to solve the matrix equation. We need to solve the matrix equation A minus lambda I into x is equal to 0. If I say this is B, suppose this is Bx is equal to 0. Right? So this is like solving system of homogeneous equations. This is where it gives you system of homogeneous equations. Right. So for this, how do you solve system of homogeneous equations or matrix equation? Consider augmented matrix A minus lambda I comma O and reduce it to echelon form. Right. Now here, what do I mean by A minus lambda I is nothing but A matrix A minus lambda into I. That is, suppose A is n by n matrix minus lambda into I is identity matrix which is also n by n. This is what we mean by A minus lambda I. Then after solving this, from the echelon form we will, from the echelon form, if this system has a non-zero solution, then lambda is an eigen value. If it has only zero solution, that is x is equal to 0, then lambda is not eigen value. This is a procedure to do whether a given scalar lambda is an eigenvalue for a given matrix or not. Now let us understand this more by taking out an example. So here I am taking an example. Lambda is equal to 1, and then a is equal to 4 minus 2 3 0 minus 1 3 minus 1 2 minus 2. Then check if lambda is an eigenvalue of A solution. So, right. So, if lambda is equal to 1 is an eigenvalue of A, then the equation, then I will say there exists a vector x not equal to 0 such that Ax is equal to lambda x. That implies the equation Ax minus lambda x is equal to 0 has a non-zero solution. That implies the equation A minus lambda I into x is equal to 0 has a non-zero solution. So if it has to be an eigenvalue, it must have a non-zero solution. So consider A minus lambda I. Now let us see how to write A minus lambda I. What is A given to us? 4 minus 2 3 0 minus 1 3 minus 1 2 minus 2 minus lambda into lambda is here 1 for us. So I will straight away write this as 1 into what is I means here identity matrix, that is what is which order this is 3 by 3, so take 3 by 3 identity matrix. If it is a 2 by 2 matrix, take a 2 by 2 identity matrix 0 0 1, which is also of 3 by 3 order. That is how do you simplify this? So this is 4 minus 2 3 0 minus 1 3 minus 1 2 minus 2 minus 1 multiply with this 1 0 0 0 1 0 0 0 1. So this will be equal to, you can check here, 4 minus 1 minus 2 3 0 minus 1 minus 1 3 minus 1 2 minus 2 minus 1, which is equal to 3 minus 2 3 0 minus 2 3 minus 1 2 minus 3. See, the same thing I can directly write. We can also write A minus lambda I is equal to, so whatever A is there, from that subtract, only in the diagonal elements subtract. So let me take for this 2 3, and then here I am not changing, 3 minus 1 2, and here it will be minus 1, minus 1, minus 2, minus 1. So simply what can we write? Directly we can write this matrix without even much calculation. So this is nothing but 3, 2, 3, 0, minus 2, 3, minus 1, 2, minus 3. Directly also you can write, or you can take some steps to write like this. A minus lambda. Directly you can write. Right. So after that, what do we have to do? What did we get? We have to consider this one, a minus lambda I into x is 0 means what is the system here? 3, 2, 3, 0, minus 2, 3, minus 1, 2, minus 3 into what will be x here? X should be, because it should be multiplied with, if this is a 3 by 3 matrix, it should be 3 by 1. So you should have here x1, x2, x3 is equal to, so if you multiply 3 by 3 and 3 by 1, you will get a 3 by 3 3 by 1 matrix 0, 0, 0. So to solve this system of equations, so we have to solve this system. So for this, what do we do? How do we solve system of equations? Consider augmented matrix. Augmented matrix. Which augmented matrix we have to consider? A minus lambda I with 0. That is, I will take the matrix 3, 2, 3, 0, minus 2, 3, minus 1, 2, minus 3, 0, 0, 0. And reduce this to echelon form. Reduce it to echelon form. So first, what was the operation? This is the pivot position, and then this is already 0, this I have to make 0. So for R3, R1, or I can say 3 R3 plus R1. So let me do that. 3, 2, 3, 0, and 0 minus 2, 3, 0, and this will be 0. And next one is 3R3, 3 to 6, plus 2 is equal to, this is 3 minus 2, 3, or 2, 3. Let us check once. I have a doubt in this. Okay, let me check the given the question. 4 minus 2, 3. So I think from here it is minus 2, and then this will be also minus 2, and this is also minus 2. So this is also minus 2, right? This is minus 2. And then 3 to 6 minus of minus 2 is 4, and then minus 9 plus 3 is minus 6, and then 0. So this pivot position is over. Next pivot position is this, and we want to make this 0. So for R3, so R3 plus 2 times R2 will give you 0. So this will make you 3 minus 2, 3, 0 minus 2, 3, 0, and 0, 0, and minus 6 plus 6, this will be also 0. So pivot positions are completed. This is reduced to echelon form now. Now we need to, this will always have a solution because it is a homogeneous system. Now we have to check whether it has a non-zero solution. That is what you need for the eigen. So for this, what do we write? I will write R1, this is R2. So R1 implies I have 3x1 minus 2x2 plus 3x3 is equal to 0. And R2 implies, this is equation 1. And then R2 implies we have minus 2x2 plus 3x3 is equal to 0. This is equation 2. Now you have to get the solution. You have to find the solution for it. Now, so 2 implies I can write minus 2x2 is equal to minus 3x3, which implies x2 is equal to 3 by 2 x3. This is equation 3. x2 value you got it as 3 by 2 x3. Now let us substitute this in. Substitute 3 in 1. So you will get the equation 3x1 minus 2 into 3 by 2 x3 plus x3 is equal to 0, which will give you plus this is 3x3 which implies you have 3x1 minus 3x3 plus 3x3 is equal to 0, which implies 3x1 is equal to 0. That this implies x1 is equal to 0. So I got x1 value. We got x1 value. We got x2 in terms of x3. But there is anything else about x3. You cannot decide anything because x2 and x3 are depending on each other and x1 is 0. Therefore, we have x is equal to x1, x2, x3, which is equal to x1 is 0, x2 is 3 by 2 x3, x3 is x3. This I can write it as x3 into 0, 3 by 2, 1, or this is equal to, I can say x3 multiply 0 into 2, 3 by 2 into 2, 1 into 2, so divided by 2, it will be compensated. So this is equal to, I can say if I take this x3 by 2 as k, this will be 0, 3, which is 2. So I can say therefore, there exists x vector x is equal to, this is x1, x2, x3, which is x1, x2, x3, which is a multiple of k032. So this is not equal to 0, 0, 0 for k not equal to 0. So what do you mean by that? That implies the equation ax minus lambda x is equal to 0 has a non-zero solution also. Non-zero solution also. And that non-zero solution, I will take it as that non-zero solution. Only I will take 0, 3, 2 is the corresponding eigenvector for the given lambda is equal to 1. Hence, lambda is equal to 1 is an eigenvalue of A. This is the way how do we determine whether a given value is an eigenvalue or not. So let us do one more example on the same. So let us take the second example. So example 2. So is lambda is equal to 2 an eigenvalue of matrix A is equal to 3, 2, 3, 8. Then give reason whether it is or not. So let us take the solution. Here we are given with A is equal to 3, 2, 3, 8, a 2 by 2 matrix, and the lambda is equal to 2. So what do we write? If lambda is equal to 2 is an eigenvalue, then there should exist a non-zero vector, that is x not equal to 0, such that Ax is equal to lambda x. That is, we have to find a non-zero solution for Ax minus lambda x is equal to 0 if exists. If that exists, then you will say it is it is an eigenvalue. If it doesn't exist, then you will say it is not an eigenvalue. That implies, consider, so this I will write it as a minus lambda I into x is equal to 0. This equation we will consider and we will solve one. To solve one. So what is a minus lambda I is equal to? A minus lambda I means we will take A matrix A. What is matrix A? 3, 2, 3, 8. In this minus you will say lambda, here you will substitute. This is only A minus lambda I. In the diagonal you will subtract lambda. That is A minus lambda I, which is equal to, what is lambda value here? Lambda value is given as a 2. So subtract that, 3 minus 2, 2, 3, 8 minus 2, which is equal to 1, 2, sorry, 8 minus 2, this is 1, 2, 3, and then 6. Now to solve one, consider augmented matrix of A minus lambda I with 0, that is equal to, so you have A minus lambda is 1, 2, 3, 6, 0, 0, and reduce it to echelon form. So let us do it quickly. This is pivot. So apply row transformations R2 for R2, R2 minus 3 R1. So this is clearly, here you can observe it is very simple. So you got here that 0 and 3 minus 3 0, 6 minus 6 0, 0. So here what is x for us here? If you go back and check here, a minus lambda I into x is 0 means here you can write x is equal to x1, x2. Why? Because here a minus lambda I will be a 2 by 2 matrix. With what you will multiply with x1, x2. This should be multiplied with this. So we have how many variables here? x1, x2. This implies I have, this is only first row, you have second row is non-zero. So R1 implies you have x1 plus 2x2 is equal to 0, which implies x1 is equal to minus 2x2. So therefore what do you have here? That implies the vector x is equal to x1, x2, where x1 is minus 2x2. When you choose x1 as minus 2x2, x2 will be as it is the same x2. So this I will write it as x2 into minus 2, 1. Therefore, there exists a non-zero solution x is equal to minus 2, 1, not equal to 0. I can say this is not equal to 0, 0 for the equation 1, whatever the equation implies x is equal to minus 2, 1 is an eigenvector, corresponding to lambda is equal to 2 for A. So there exists eigenvectors implies lambda is equal to 2 is an eigenvalue of E. And here I can give some note point. You are saying here x is equal to, we are saying x is equal to, actually it should be some x2 into minus 2 1 you are writing. That is, I can say, suppose it is k into minus 2 1. What is this k? So if k is equal to 1, then what will be x? Minus 2 1. Then if I take k is equal to 2, if k is equal to 2, then x is equal to 2 into minus 2 1, which is equal to minus 4 2. This is an eigenvalue, eigenvector. This is also eigenvector of E. Similarly, if I take k is equal to, suppose like this, if I take minus 5, then x will be equal to minus 5 into minus 2 1, which is equal to 10 minus 5. This is also eigenvector of A. So what do you mean by that? That imply like this. In this way, for lambda is equal to 2, we have minus 2 1, minus 4 2, and so on, 10 minus 5, and so on. That is, any multiple of minus 2 1 is an eigenvector. Is an eigenvector for the single eigenvalue lambda is equal to 2. So what do you mean by that? So I can write hence we can generalize that corresponding to a single eigenvalue, there can exist more than one eigenvector, more than one eigenvector. That is, if suppose if I have I can say corresponding to lambda, if suppose x is an eigenvector, then like 2x is also an eigenvector, then corresponding minus 5x is also eigenvector. Like that, any multiple kx for any scalar k. All these are eigenvectors. So corresponding to one single eigenvalue, there can exist more than one eigenvectors, but I will say here, but for an eigenvector, there is only one eigenvalue. That means here, if you see here, for x eigenvalue is lambda, then x cannot have any other eigenvalue. That is what we have here between eigenvalues and eigenvectors. Here we have practice problems for eigenvalues. So first one is, show that 7 is an eigenvalue of the matrix, a 2 by 2 matrix is given, and find the corresponding eigenvector. And the second question, is lambda is equal to minus 1 an eigenvalue for the matrix? If so, find the corresponding eigenvector.